Here we're going to look at the factorisation method of difference of two squares and how we can use the fact that if we've got something squared, take away something squared, that we can write it in a special way. Okay, to illustrate this, I've got this double bracket here, x minus y, x plus y. So let's first just multiply out this bracket. So x times x times y. So x times x is x squared, and x times plus y would be plus xy. And then my second term's minus yx or minus xy, because generally we write it in order. And then minus y squared. Okay, collecting like terms, I've got a plus xy here, a minus xy here, so that just disappears, and I would be left with x squared minus y squared. So, if I have got something squared, take away something squared, that means that I can write it in the form x minus y, x plus y, x minus y, x plus y. Because we've shown that when you multiply that bracket out, we get something squared to take away something squared. Okay, here we're going to show this in practice with numbers. So here I've got 5 squared to take away 4 squared. So let's do this numerically at first. 5 squared is 25, 4 squared is 16, 25 take away 16 is 9. Okay, so that's my one method I can do. Or, I've got something squared, take away something squared, so I can do 5 minus 4, 5 plus 4. 5 minus 4 is 1, 5 plus 4 is 9. All this means is 1 times 9. Okay, so we see that they do match up. The methods that we're doing do match up. And although numerically it would probably be more straightforward to do it with this, when we've got algebra, our life is going to be so much easier by going with this method here. Okay, here I've got r squared take away 81, and my task is to factorise this. So we have to check, is there a difference of squares? So we can see here we've got r that is squared, but we're taking away 81. What is really important that we are really capable of is knowing our square numbers. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. All the square numbers up to 12 squared. So we should be able to quickly identify that 81 is the exact same as 9 squared. Now I've got something squared, take away something squared. So I can write it in the form r minus 9, r plus 9. When I've got something squared, take away something squared, I can just do r take away 9, r plus 9. Okay, this example is slightly different because I've got the x squared here. Okay, but we'll just follow through the process. Do I have something squared take away something squared? Not at the moment, because this 16 isn't squared. I'll need to change it. But I do know that 16 is a square number. 16 is the same as 4 squared. So I'm doing 4 squared take away x squared. So now I've got something squared to take away something squared. So I can just write it in the form 4 minus x, 4 plus x. There is a way to actually check your answer. If you were to multiply out this bracket, I'm just going to move this up. If you were to multiply out this bracket, you would get 16 plus 4x minus 4x minus x squared, and collecting like terms would give us 16 minus x squared, and we should hopefully be able to note that when we multiply out the bracket we get exactly back to the question we've got. That means that we have factorised properly here. In this final example, these are the sort of questions that catch people out. So here we've got 64a squared take away 9b squared. So although I've got something squared take away something squared, what I need is something to be all squared take away something to be all squared before I can factorise. So is there another way that I can write 64a squared? So 64 is the same as 8 squared. So if I put 8a inside a bracket and I put a squared term outside, all that means is that this is the exact same as this. Okay, I've got something all squared here, only the a was squared. And with this second term, only the b is squared. I want something to be squared inside brackets. And we should find that we would get 3b. Now I do have something squared, take away something squared, so I can just fire ahead and go 8a minus 3b and 8a plus 3b. Remember, you can check if you've done this properly. If you multiply out this bracket and collect like terms, you should get back to this answer here.